We're going to look at some very important ideas in linear algebra that their understanding is very important in figuring out the whole of linear algebra. It's going to be very difficult to understand it without these basic ideas. So the first one that's very often talked about is pivots, and you're probably wondering what actually is a pivot. And a pivot is very simple. It's the first non-zero element working from the left in a matrix which is in this what you call echelon form. And some textbooks often refer to it as the leading entry, which is a far simpler way of thinking about it. So imagine this matrix here. This is in echelon form, which I'll explain what that means in a second. Now if we look at the first element that's not zero, this is the first one we find. And there's a zero here, and it's the first non-zero element in this row. These are the pivots. And each of these columns is simply called a pivot column, very unsurprisingly. And you also have free variables, which are the other non-zero elements. So basically, they're not pivots. So these will be the free variables because they're not pivots and they're not zero. And you notice this column has no pivot variables in it. So that's referred to as a free column. And pivot columns and free columns have properties associated with them. So this echelon form. Echelon form is quite simple. It's a matrix that follows a set of rules. The first rule is that the zero rows are at the bottom. So if you look back at this matrix here, this row is all zeros and it's at the bottom of the matrix. And also every pivot must be to the right of the pivot above. And implied by this, which is a quick check that you can use, is there should be a zero below the pivot. So just bear that in mind. So when you look at a matrix, you should see the pivots and then see a zero below the pivot. If there's not a zero below the pivot, it's not going to be an echelon form. And getting a normal matrix into echelon form is just done by row operations. Say you had this matrix here, you could just perform a very simple operation. You take row 2 to become row 2 minus row 1, so taking this row, subtracting this row, which leaves this here. See 1 minus 1 is 0, 4 minus 2 is 2, 2 minus 1 is 1. And you'll notice that if you add row 1 and row 2, you end up with row 3. So you can turn this into zero row very simply. You just make row 3 row 1 plus row 2, add these together, and add these together, and then subtract row 3. So you're doing 1 plus 0 plus 1, which is 0, 2 plus 2, which is 4, subtracting 4 is 0, 1 plus 1 is 2, subtract 2 is 0. This matrix is in row echelon form. Remember the quick check, there's a pivot there, and there's a 0 below it, there's a pivot there, and there's a 0 below it. This is the matrix we had earlier that looked like this. So you just play around with some row operations and you should end up with the matrix in echelon form. And this associated idea, you've got the rank of a matrix, which is very useful in linear algebra. And the simplest definition is it's the number of pivots in a matrix when it's put in this echelon form. The matrix that we saw earlier that had 2 pivots, so the rank of the matrix is 2, and it's written as rank of A, or sometimes shortened to this RKA. And also you may as well remember that the highest number of linearly independent rows is another definition of the matrix. Rank of a matrix is often used. I've got a video explaining what that is. And that's those 4 important ideas. Hopefully it's going to make linear algebra a little bit easier.